This is the video for Accelerated Geometry on Section 4-2, Day 2 on solving radical inequalities. Key vocabulary is radical inequality. The essential question we will be answering is how do you solve radical inequalities both algebraically and graphically? A radical inequality is an inequality that contains a variable within a radical. You can solve radical inequalities by graphing or using algebra. A radical expression with an even index and a negative radicand has no real roots. Think about an even index, so that could be the square root and a negative radical of 4. We know that that would be plus or minus 2i, which is the imaginary numbers. Or you could do like the fourth root of negative 15. That would be an imaginary answer as well. So all this is saying is if you have an even index and a negative underneath, then you have no real roots. Okay, something else we want to remind ourselves about solving with inequalities is that if you multiply or divide by a negative, you must flip the sign. So example 1 here, we have the square root of 2x minus 6 plus 3 is less than or equal to 9. So what I'm going to do is I'm going to, opposite of adding is subtracting. So that leaves me with the square root of 2x minus 6 is less than or equal to 6. In order to get rid of the square root, I'm going to square both sides. So that's going to give me 2x minus 6 is less than or equal to 36. Opposite of subtracting is adding, so I'm going to add 6, so that gives 2x is less than or equal to 42. Opposite of multiplication is dividing, so that gives me x is less than or equal to 21. Now, we're not done here because we have a radical involved. So we have to go back and check the domain on this radical. And to do that, you're going to take what's underneath the radical, and that has to be greater than or equal to 0 because we can't have a negative under the radical. So then I'm going to add 6 over, so that gives me 2x is greater than or equal to 6, and divide by 2, so that gives me x is greater than or equal to 3. So we have that x is less than or equal to 21, but also that x is greater than or equal to 3. So our final answer would be that 3 is less than or equal to x, because that's the same thing as saying x is greater than 3, which is less than or equal to 21. Let's try another one. So if I look at this problem, opposite of addition is subtraction. To get rid of the square root, I'm going to square both sides. Opposite of subtraction is addition. But before I say this is my answer, I'm going to go back and look at my radical. So I have that x minus 3 has to be greater than or equal to 0 because we can't have a negative. So this tells me x is greater than or equal to 3. So then we would have the x is greater than or equal to 3, so that's the same thing as 3 is less than or equal to x, and that x is less than or equal to 12. Let's try another one. Now we have that the cubic root of x plus 2 is greater than or equal to 1. So in order to get rid of this cubic root, since there's no multiplication or addition or subtraction to the whole thing, we can just cube each side. So that's just going to give me x plus 2 is greater than or equal to 1. Opposite of adding is subtracting. So that gives me x is greater than or equal to negative 1. Now, if we remember, with a cubic root, there's no domain restriction, so I don't have to worry about solving for that other thing like we did on the square roots. because it's not an even index here. And when we take the cubic roots, we can have negative numbers. So our answer to this one is just that x is greater than or equal to -1. Let's try another one. We have the cubic root of 4 minus 2x is less than or equal to 7. So I'm going to cube both sides. That's going to give me 4 minus 2x is less than or equal to 343. Opposite of adding 4 is subtracting 4, so that gives me negative 2x is less than or equal to 339. Divide by a -2. As soon as I go to write that divide by a -2, a bell should go off that I'm dividing by a negative, so automatically the sign gets flipped, so that becomes a greater than or equal to. And 339 divided by -2 is -169.5. And again, we can have negatives under a cubic root because this isn't an even index. So our answer is just x is greater than or equal to -169.5. Now we're going to take some of the same problems we just worked, and we're going to look at them on how to solve by graphing them. So the first thing we're going to do is we're going to take this whole expression on the left. Oh, let me use the same colors that my graphs are. So this expression on the left here, we're going to type this into y1, and the 9 is going to be typed into y2. So that when you graph it, your graph will look something like this. And I want to know, when is this blue graph less than means below 9? So when is the blue graph below this red line? And if we look, we can see that it's first things first, we need to calculate this intersection point. So if we calculate this intersection point, we will get that that's at 21, 9. And then if you look, it's everything to the left here is below that red line. However, the graph originally starts for this blue, for the radical, at 3, 3. But we're only concerned with these x values. So since it starts at 3 and it ends at 21, we would have x is less than or 3 is less than or equal to x is less than or equal to 21, which is the same answer that we got on example 1. On example 6 here, we're going to type this left side into y1, type 5 into y2, and again, less than means below. So when is the blue graph below the red graph? So first thing I'm going to do is calculate their intersection, which happens to be right here at 12, 5. And if you look, the blue graph is below the red line, everything to the left again. So we need to know where this starts, which in this case is at 3, 2. But again, we're only concerned with the x values. So it starts at 3 and it ends at 12. So on example 7, the cubic root of x plus 2 goes in y1. And again, if you don't know how to type in the cubic root, you could always type it in as x plus 2 raised to the 1/3. It will give you the same thing. And the right side is 1, which we're going to type that in y2. But now we have greater than, which means we want to know, when is the blue graph above the red line? So if we look, this blue graph is above the red line, everything to the right of this intersection. So first thing I'm going to do is going to second, trace, and then to intersect and calculate that intersection point, which happens to be at -1, 1. And it's everything to the right, and right means greater than. So our answer is going to be x is greater than or equal to -1. One more example for us, an application problem. So we have that the time t in seconds that it takes a car to travel a quarter mile when starting from a full stop can be estimated by using the formula, and it's there for you, where W is the weight of the car in pounds, P is the power delivered by the engine in horsepower. If a quarter mile time from a 3,590 pound car is 13.4 seconds, how much power does it take its engine to deliver? Round your answer to the nearest horsepower. So first things first, it says if a quarter mile time from a 3,590 pound car, so this is giving me a weight, is 13.4 seconds. This is giving me a time. How much power tells me I'm solving for P does it deliver? So we have our formula of T equals 5.825 times the cubic root of W over P. And all I'm going to do now is plug in my given information. So I have that T is 13.4. And I know that W is 3,590. And now we're going to solve this for P. So the opposite of multiplication here is division. So I'm going to divide both sides by 5.825. And don't round too short here. So I rounded 4 decimal places. So that gives me 2.3004. And then since I'm trying to get rid of that cube root, I'm going to cube both sides. Ooh, that's an ugly 3. So 2.3004 cubed gives me 12.1733. And then I want P by itself, so first I have to multiply both sides by P. So that's going to give me 12.1733P equals 3590. And then I want P by itself, so I'm going to divide by 12.1733. So I get P equals 3590 divided by 12.1733. And if we round that to the nearest horsepower, we will get roughly 295. So we can say that the engine delivers about 295 horsepowers. Again, please make sure that if you are having issues with solving by graphing for these inequalities, that you bring your calculator to class so that you can ask the questions that you need to ask.